Hi, good day, students. In this clip, we're going to be going over some examples on trigonometric identities, 1 to 4, 1 to 8 in part 1 practice problems. To do these examples that I'm going to go over, I am assuming that you should know this set of identities. You should know your reciprocal identities, your quotient identities, and your Pythagorean identities. If you don't know these identities, you can just, if you don't have the master, just write them down, or you can print out an identity sheet off of the internet, okay? Because these are the identities I'm going to use for the following examples. All right, with that in mind, let's go ahead and get started. We're going to take a look at number 1. So for number 1, we're going to prove, well, the general instructions for all the problems is prove the given, um, trig identities. Okay, they're all true. We're just proving them. Okay. All right. So for number 1, we're asked to show that sine x plus cotangent x equals secant square x cotangent x. Okay. So in order to do these examples, what I like to do, strategy I like to do, I like to express everything in terms of the two parent trig functions. The two parent trig functions are sine and cosine. So I ask myself, how can I express everything in terms of sine and cosine? So instead of focusing on 6 different identities, I just narrow it down to 2 on both sides. Okay, so that's the strategy I'm going to be using here. So let's take a look at the left side and the right side. Let's look at the left side first. How can I express everything in terms of just sine and cosine, and then we'll go from there. So on the left side, I have tan. I know that tan x is sine x over cosine x from your quotient identities. And I also know that cotangent x is what? The reciprocal of tan, or just the reciprocal of this ratio right here, so it's cosine x over sine x. Okay? Secant is the reciprocal of cosine, so secant x is 1 over cosine x. And last but not least is cotangent x, which is cosine over sine. We already have it here. Alright? So I'm going to use these substitutions here to express both sides of my equation in terms of just sine and cosine. Alright? Alright, let's go ahead and do this. So for tan, I'm going to have sine x over cosine x. And then for cotangents, just reciprocal, I'm going to have cosine x over sine x. We already established here that cotangent is cosine over sine. Secant x is going to be 1 over cosine x. This one is, we're going to square it, okay, because we have a square there. 1 over cosine x squared, and then cotangent is, what is cotangent? Cosine x over sine x. Okay. All right, let's proceed. On this side right here, we have 2 fractions. So how do we add fractions, right? Let's say we wanted to add 1/3 plus 1/2. How do I add this? Think back to middle school or elementary school whenever you learn fractions. The denominators must be the same, right? If they're co-primes, we have to find a number that they will go into the smallest number, known as the LCD. The LCD in this case is 6, so I just times this by 3, top and bottom, times this by 2, top and bottom. So I have 2 over 6 plus 3 over 6. Denominators are the same. We have 5 over 6 as your combined fraction. Okay? So that's exactly what we're going to do here. We need to find the LCD of cosine and sine. Since they're co-prime functions, I just need to find the LCD of these two. So all I'll do, just like we did here, is multiply this side by sine x, top and bottom. And then on this side, cosine x at the bottom and at the top, okay? So we preserve equality. The goal again is to make the denominators the same so we can add the fractions, alright? So this multiplication will help us accomplish that. So sine x times sine x is sine square x over sine x cosine x. And then cosine x times cosine x is cosine square x over I can also write this as sine x cosine x, because we know that multiplication commutes, right? All right, and then on this side right here, I'm going to have 1 over cosine square x. But instead of writing cosine square x, I'm going to write it as cosine x times cosine x. That's what square means, right? You multiply something by itself. And then times cosine x over sine x. Okay? We know 1 square is just 1, so we can have the 1 on top. But this one I can break it down like this. Now let's take a look at the left side again. These two fractions have the same denominator, so I can combine the denominators as 1. As we did on this example fraction we did over here, the denominators is just written as 1. Sine x, cosine x. And then on the top, we're going to have sine square x plus cosine square x. Alright? And then over here, you notice that we can do a cross reduction, right? So we have cosine here and a cosine here, so cosine goes here 1, cosine goes here 1. So we'll have 1 over cosine x sine x. Okay? Alright. Now what can we do here? On the left side, sine square x and cosine square x. That looks familiar. That looks like a trig identity, right? That is the Pythagorean identity for sine and cosine. So sine square x plus cosine square x based on the Pythagorean identities equals 1. Okay? So I'm going to replace that whole top with 1. So I'm going to have 1 divided by sine x cosine x equals 1 over, since multiplication commutes, cosine x, sine x is the same thing as sine x cosine x. Since the left hand side is equal to the right hand side, we're done. And have your box right here. So the goal is to get the left hand side to be equal to the right hand side, and we've accomplished that. Alright, with that in mind, let's move on to question 2. In question 2, we have to show that sine square x is equal to 1 minus cosine x times 1 plus cosine x. Alright, so in this case, these two parentheses are begging us to do something, which is distribute. So we'll want to distribute this first and then see what happens. This is a difference of squares in factored form, so if you want to do this mentally, simply 1 minus cosine square x, okay? But I'm going to act as though we don't know that trick, so I'm going to work it out. So what I'm going to do is I'm going to distribute this 1 to the 1, and then to cosine, and then cosine to 1, and then to that, okay? You can call it FOIL or whatever your teacher showed you, but you understand what I'm doing, right? So sine square x is nicely simplified for us, so we just leave it alone. It's one of the parents, right? And then this one, 1 times 1 is 1. 1 times cosine x is positive cosine x. Negative cosine x times 1 is negative cosine x. Negative cosine x times cosine x is minus cosine square x, okay? You notice that the middle terms on the right are both opposites, so they cancel each other out. This cancels that out. And then now we're going to have sine square x equals 1 minus cosine square x. Okay. Now, what on earth is this? Can I substitute this with something else? Well, let's write down our Pythagorean function for sine and cosine again. Pythagorean identity, sorry. So sine square x plus cosine square x equals 1. Now, what happens if I subtract cosine x from both sides? If I subtract cosine square x from both sides, that leaves me with the equation sine square x equals 1 minus cosine square x. Alright? So guess what? I can substitute the left side of this equation with sine square x. So we're going to have sine square x equals sine square x. So since the left hand side is equal to the right hand side, we are done. Okay? Alright, let's move on to question number 3. We want to simplify, we want to work on the identity 1 minus cosine square x over, we want to show that this is equal to tan square x. Okay? Alright, so on the left side, can I condense this? Anytime you have multiple terms combined by plus or minus, you ask yourself, can you condense them using an identity? Well, let's take a look at what we just did in question number 2, though. We found out that sine square x is equal to 1 minus cosine square x. So We can condense this into simply sine square x by using that identity, by using the Pythagorean identity. So this numerator right here can be condensed into sine square x over cosine square x. So the left-hand side has been written in terms of the parent trig function, sine and cosine, so let me leave it alone. And let's go to the right-hand side. So on the right-hand side, we have tan. What is tan? We know before that tan x is sine over cosine, right? So if I do that right here, I'm going to have sine x over cosine x for tan. We're going to square that, okay? When you distribute your square inwards, you're going to end up with sine square x over cosine square x equals sine square x over cosine square x. So the left-hand side is equal to the right-hand side. We are done. Okay? All right, let's move on to question number 4. So question number 4, we're going to show that, we want to show that tan square x multiplied by cosecant square x equals 1 plus tan square x. Okay? So remember, the goal again is to express everything using a parent trig function, sine or cosine, and then we condense and go on from there, right? So tan, I can write tan. We know tan is sine over cosine, right? Tan x is sine over cosine. Cosecant is a reciprocal of sine, so it's 1 over sine x, and then we know what tan is. Alright, so tan right here, I'm going to substitute it with sine x over cosine x. We're going to square it since the tan is being squared here. For cosecant, I'm going to have 1 over sine x, and that's going to be squared also. And then here I'm going to have 1 plus, instead of tan, I'll have the same scenario, sine x over cosine x squared. Okay? Alright, now on the left side, I'm going to write it as sine x times sine x. I'm not writing it in a separated form, in a fracted form for a reason, okay? And then on the bottom, I'll just keep cosine square x as 1. Or let's just be consistent. Let's do the same way top and bottom, okay? So on the bottom here, it doesn't really matter how I write a cosine since it doesn't have anything to cancel. Okay, so cosine x times cosine x. And on the right side, I have 1. 1 times 1 is just 1. And then here I'll have sine x times sine x equals 1 plus. On this side right here, I'm going to express this as sine square x over cosine square x. The reason I didn't break these down is because nothing cancels, but here there's a possibility that stuff will cancel out, so that's why I broke it down like this, okay? So here on the left side, I see this sign, and this sign cancels out. 1, sign goes here 1, sign goes here 1. So on the left side, you're left with 1 over cosine square x, okay? And that equals, now here you have a fraction. This is 1, it's a whole number, right? It's not a fraction, so let's express it as a fraction. 1 over 1. I need the denominators the same so I can combine. So I times this one by cosine square x top and bottom. Cosine square x at the bottom. And cosine square x on the top. And then that's going to leave us with cosine square x over cosine square x plus sine square x over cosine square x. Okay, what did I just do on the right side? My goal is that whenever I have two fractions, I want the denominators to be the same. So the LCD of 1 and cosine square x is cosine square x, okay? This is already the LCD, so I just need to change this by multiplying by cosine square x on the top and on the bottom. Alright, so denominators are the same, which is excellent. The left side is nicely simplified. Let me leave it at 1 over cosine square x. I can write it as a secant square, but let's leave it at 1, okay? And then here, since the denominators are the same, they can be combined into 1, cosine square x. And then at the top, you have cosine square x plus sine square x. Now, what is cosine square x plus sine squared x? Well, since I know that sine square x plus cosine square x equals 1, what does that tell me? Remember, addition commutes, right? A plus b is equal to b plus a, so I can switch this around. This also tells me that cosine square x plus sine square x equals 1, okay, because it commutes to the property of addition, right? Just like multiplication. So, in essence, this piece right here is just 1. So, written as just 1, okay? So, basically, I can rewrite this as 1 over cosine square x equals, oh wait, there's a square here, equals 1. Or let me just do this way. What if I switch it around? I can switch it around. I can just say, well, let me just make it 1. Okay, 1 over cosine square x. I hope you got this because this is the same thing as that. Okay? Alright, so since the left hand side is equal to the right hand side, we are done. Alright? Okay, now let's move on to question number 5. From question 5, we're going to show that tan square x is equal to secant x plus 1 times secant x minus 1. Okay? Now, on the right side, I'll have to distribute this first before I start changing it into the parent trig function. This needs no distribution, so I'm just going to change it up directly. So it's going to be sine square x over cosine square x. Okay? Because remember that tan is sine over cosine, right? Tan x is sine over cosine. So that's basically what I used over here. Alright, so on this one, I'm just going to distribute this out and then see what happens. So if I distribute, I'm going to have secant square x minus secant x plus secant x minus 1. If you notice in the center that these two are opposite, so they cancel out, right? So bring this down, sine square x over cosine square x equals secant square x minus 1. Alright, so what on earth do we do here? How about now that it hasn't distributed, now I can now focus on changing this into the parent trig functions and then see what I can do from there. Okay, so what on earth is secant? Secant x is 1 over cosine x, right? So that's what I'm going to do here. So just leave the left side alone, since it's already in terms of sine and cosine. Sine square x over cosine square x. And then secant square x, I'm going to write it as 1 over cosine square x. I'm squaring it because there's a square here. Since this is a fraction, I like to express 1 as a fraction, which is 1 over 1. Now, how do we combine these two fractions? Do you want to make the denominators the same? The LCD of 1 and cosine square x is cosine square x. So I'm going to multiply this, the left side of the equation, by cosine square x, top and bottom, so that the denominators match, and then I can combine them. Okay. So we're going to have on the left side sine square x over cosine square x equals 1 over cosine square x minus cosine square x over cosine square x. Voila! The denominators are the same. Now I can combine them, right? So just bring down the left side, sine square x over cosine square x. And since the denominators are the same, I have the right to combine them as 1, because that's how you add fractions. And then on the top, we have 1 minus cosine square x. Okay? Now, what on earth can we do from here? Can I condense this top right here? This looks like a variation of the Pythagorean identity, right? Because I remember what we did earlier. We said that sine square x, wrong color, use red. We said that sine square x plus cosine square x is equal to 1, right? And then we subtracted cosine square x on both sides, remember? Oh boy. What's this? Subtracted cosine x square x on both sides, and then we had we ended up with the identity sine square x equals 1 minus cosine square x, right? You can do this in your head. I'm just showing it again just for emphasis, just to repeat. Repetition purposes. Anyway, so there you have it. Okay, so based on this, I can replace the top like I did in examples 3 and 4, I think. No, 2 and 3. I can replace this with sine square x. So I'm going to have sine square x over cosine square x equals 1 minus cosine square x is just sine square x over cosine square x. Left hand side is equal to the right hand side, and we are done. Well, okay. All right, now let's move on to example number 6. So for example 6, we need to prove that cosine square x. We want to prove that cosine square x plus tan square x cosine square x equals 1. Okay. So we're not even going to bother with the right side because this is as nice as it gets. So leave that alone. Let's focus our energy here. Alright, so we need to ask ourselves, can I condense? Can I factor? All that, if I can simplify it as much as possible, then I'll express it as a parent trig function. Okay? Now, notice there's a cosine here and a cosine here. You have a common factor on the left side. Since you have a common factor on the left side, see this cosine right here and this cosine? I can factor it out, right? When you factor out, it's as though you were dividing, right? So when I factor out cosine, I'm going to factor out a cosine. I'm going to have cosine square x on the outside. When I factor out cosine from cosine, it's as though I was dividing by cosine, right? So as though I was dividing this one by cosine square. You don't have to do this. I'm just trying to make it obvious what I'm doing. When you're factoring out, the term is that as though you're dividing, right? So when you divide these two, you're going to get 1, right? So factor out 1 out, factor out cosine square x out of cosine square x, I'm left with 1, because this and this is that, plus, if I factor it out of this side, these two become 1, so I'm just left with tan square x equals 1. Okay? Now, what can I do next? I have 1 plus tan square x. There's a problem. Can I express tan as a ratio, as using the parent trig function? Of course I can, right? Because tan is sine of a cosine, right? Notice I'm going over the identities over and over again because I need you to memorize them. If you have them memorized, it's much easier to do this like at high speeds, okay? So let's do that. So cosine square x is one of the parents, so I'll leave it alone. 1 plus, instead of tan square x, I'm going to have sine square x over cosine square x equals 1. Now, since I already have I have a fraction in here, I need to work this fraction out, right? So how do I do this? Since this is a fraction, we make this a fraction. We now have two fractions that we have to combine, so we need a common denominator in order to combine the bottom, okay? We need to make the denominators common. So to make that happen, we need the LCD of 1 and cosine square, which is cosine square. So I'll times this one with cosine square, x on the bottom, and on the top, oh boy, I don't know if it's the same, cosine square x. Sorry about this, anyway, so times top and bottom by cosine square x. This looks terrible. Apologies. So when you do that multiplication, that's going to help us have the same. I'm going to alter this a little bit so I can create a cosine square or something. Alright, so this one is going to be times this one by cosine square x. That's the top, okay? Alright, so we're going to have, on the outside, cosine square x stays undisturbed. Inside, we're going to have cosine square x over cosine square x plus sine square x over cosine square x. Voila! Denominators are the same. Now we can now combine, right? So just bring down the cosine square x on the outside. And then denominators are the same. We can then combine the denominators and write them as 1. Write it as 1, which is cosine square x. And then on the top we have cosine square x plus sine square x equals 1. What on earth is this? Remember we talked about this before? Wait, what did we talk about? We said that sine square x plus cosine square x is the same thing as cosine square x plus sine square x, because addition commutes, right? So since this is equal to 1, that means this whole business right here is just equal to 1 also. Alright, so what I'm going to do is I'm going to substitute this top with 1 because it's the same thing as sine square x plus cosine square x according to the Pythagorean identity. Okay, so leave this one out here alone. Cosine square x times 1 for the numerator using the substitution here over cosine square x equals 1. Okay, now what can I do? How about I express this as a fraction? See, these two are identical, so I can cross reduce, or you can multiply and reduce, whatever you want. This one goes here 1, this goes here 1, and you end up with 1 equals 1. Left hand side is equal to the right hand side. We are done. Okay. All right, let's move on to question number 7. Question 7, we want to show that cosecant square x is equal to cotangent square x plus 1. All right, so let's try this one out. So this side right here, let me express this in the parenthetic function. I know that cosecant x is 1 over sine x, right? And I also know that cotangent x is the reciprocal of tan, which is cosine x over sine x. Okay? Alright, now let's make a substitution on the left side. On the left side, we're going to have 1 over sine square x. Okay? This one doesn't need much work, but this side will need some more work. Okay, so this cotangent square x will be written as cosine square x over sine square x plus 1. Okay, now let's deal with this side right here. I need two fractions. So write this as a fraction. This has a fraction also. So now how do we combine? We need the denominators to be the same. So we need to find the LCD. LCD of sine square x and 1 is sine squared x. So to make this match that, I need to times it by sine square x on the bottom. To preserve equality, whatever you do on the bottom, you do to the top, okay? Alright, so bring down the left side. To bring down the left side, we have 1 over sine square x equals cosine square x over sine square x plus sine square x over sine square x. This is exactly what we want. Notice that the denominators are the same. Okay? So I bring down the left side, and I'm going to have cosine square x plus sine square x over, oh boy, my line is not a line. I don't know what that is. Anyway, divided by sine square x. Okay? Notice what I did. I combined the denominators since they're the same. Okay, that's how you do fractions. Okay, let's see. What can we do here? The left side still stays the way it is because it's simplified as much as possible. Now the top right here, remember the identity? Cosine square x plus sine square x is 1. Okay? Divided by sine square x. And there you have the left hand side plus the right hand side. That means you are done. Okay? Alright. Now let's do the last example, last but not the least, number 8. We're going to prove that tan x over 1 minus cosine x minus tan x over 1 plus cosine x is equal to 2 cosecant x. Okay? So how do we do this? Let's see. On the left side, we have two fractions. So before I even start thinking about making everything sine and cosine, we have to combine these two fractions, all right? So how do we combine fractions? We need a common denominator, the least common denominator, so we can combine the fractions. What's the LCD of 1 minus cosine and 1 plus cosine? They're co-primes, so we just multiply both of them. That should give us the LCD, all right? So on the left side, I'm going to multiply by 1 plus cosine x. That's what this is, right? Times that on the top and the bottom, 1 plus cosine x. What do I multiply this by? This is 1 plus cosine, 1 minus cosine. So this one I need to do the same thing with that so they will match up. So on this one, top by 1 minus cosine x. Where'd that come from? Here, right here, okay? Just putting that here. And then down here, same thing, 1 minus cosine x. Remember, the goal again is to make the denominators identical. Alright, so what I'm going to do, you know what, I can skip steps, but I'm going to write down every single step so that you guys can really understand what's going on, okay? So if this is too slow for you, pardon me. Okay, so 1 plus cosine x times tan x divided by divided by 1 plus cosine x times 1 minus cosine x. Alright? And then on the right side, we're going to have tan x times 1 minus cosine x. And then divided by 1 plus cosine x, 1 minus sine x. Okay? 1 minus cosine x. I'm writing it down so it's clear what I'm doing. So cosecant, how about we change it to its to parent trig function? Cosecant is 1 over what? Sine, right? So let's do that. So instead of 2 cosecant, I can write this as 2 over sine x. Right? I do that. Alright, let's leave this alone. Now let's go here. What am I going to do? What on earth can I do here? Well, I can distribute, right? Distribute the terms outside the parentheses inside. So this I can distribute to 1 and cosine. And then this I can distribute to 1 and cosine also. So that gives me tan x plus tan x cosine x. And then minus, parentheses, distribute this, you have tan x minus tan x cosine x. Alright, and then you write the denominator as 1 because they're the same, right? So write out the denominator, since they're both identical, you're going to write both of them as 1 plus cosine x times 1 minus cosine x. Now, with the right side alone, 2 over sine x is nice. That's neat. Do you know why I put the parentheses here? Anytime you have a minus in front of multiple terms combined by plus or minus, you have to put the minus here because this minus affects every sign to its right hand side, okay? So if I didn't put this here, it will result in an error with my sign, okay? Alright, so now we're going to move along. So next we're going to have, now this one, we're going to distribute this minus. This minus will get distributed to this term and this term right here. So on the top, we're going to have tan x plus tan x cosine x minus tan x plus, because minus times a minus is a plus, tan x cosine x divided by 1 plus cosine x, 1 minus cosine x. 1 minus cosine x, okay? And then that equals 2 over sine x. Alright. Now, what can I do on the top? Well, we have opposites. These two are opposites, so they can cancel each other out. Right? This one, tan x and tan x are opposites, and you can cancel each other out. These are identical, right? So it's like we have 1 tan x cosine x here. Uh-oh, wrong color. We have 1 tan x and 1 cosine x here, and another tan x and cosine x here, just like you have x plus x, right? What's x plus x? 2x, right? So since we have one of this and one of this, if I combine both of them together, I have 2 of them, right? So 2 tan x cosine x, okay? Over, how about I distribute the bottom out? It's looking a little bit too complicated. I don't like that. So let's distribute this out, this one out, okay? The bottom. So if I distribute out the bottom, which I should have done earlier, but I was focusing all my attention on the top. So if I distribute the bottom out, it's basically 1 minus cosine square x, right? But let me show you the steps. So if I do 1 times 1, I have 1 times cosine, minus cosine x, plus cosine x, and if I do the last one, minus cosine square x. Okay? 2 over sine x. Now, I'm going to express the top using the parent trig function sine and cosine, so I can write tan as tan. Remember what tan is, right? What is tan x? Tan is sine of the cosine, right? Alright, so let's do that. So on the top, wait, let me, in order not to get you confused, let me simplify the bottom before I do that, okay? So I'll just bring down the top first. I don't want to do multiple things simultaneously so you don't get lost. So on the bottom, these two cancel out because they're opposites. 1 minus cosine square x. I can process the bottom a little bit more before I get rid of that tan that's annoying. So what can we do? 1 minus cosine square x, remember what we derived earlier? Well, I'm going to assume you forgot. We said that sine square x plus cosine square x equals 1, right? And then I said if you subtract cosine square x from both sides, what is that going to give you? It's going to give you sine square x equals 1 minus cosine square x, right? So that tells me that I can replace this bottom with what? Sine square x. So we're going to have 2 tan x cosine x divided by sine square x. Okay, equals 2 over sine x. Leave the right side alone, nice and neat, because it looks good. Alright, now that I have it simplified as much as possible, I'm going to now attack my tan using what we talked about earlier, which is that tan x is sine x over cosine x, right? Alright, so let's do that. So I'm going to take this one out, and then I'm going to go 2, instead of tan, I'm going to write 2 sine x over cosine x times cosine x. How about I just write this, put this over 1, put that over 1, so that everything is nice practice. Okay? And on the bottom I have sine square x. Question is it equal to 2 over sine x? Well, let's see. On the left side, cosine and cosine cancel out. So you're left with, you're left with 2 sine x on the top over sine square x equals 2 over sine x. Alright, so you can see that this cancels one of them, right? Well, let me make it obvious. So sine x, what is sine square x? It's just sine x times sine x, right? Remember, I'm showing you all the baby steps so you can understand. If you know this, you can do this in your head. You don't need to do all the steps, okay? Alright, so you see what's happening here using a law of exponents. I broke it down so it's obvious. This one takes out one of them. So you're going to have 2 over sine x equals 2 over sine x. So the left hand side is equal to the right hand side. We are done. Okay? Alright, thank you so much for watching this presentation. Please subscribe and share my video with your friends if you liked it on Facebook, Twitter, Google Plus, and whatnot. You can subscribe to my channel. Just click up here. Above here is subscribe. If you like my video, just click like here. If you didn't like it, send me an email telling me what issues you have so I can address it in future videos. Okay. More videos at notgoodserve.com. And thanks again, and have a wonderful day.